Hi class. In this video, we're going to look at how to solve for equilibrium in a partial equilibrium setting. We're first going to look at this graphically, and then we're going to look at how to solve it using math or using equations. Now this is a set of skills that we're going to use quite a bit throughout this class, and in particular, quite a bit in the next two sets of lectures. Okay, so let's start out by quickly reviewing the inverse demand curve and the inverse supply curve. So I'm going to draw a graph, and as usual, I'm going to put price on the vertical axis and quantity on the horizontal axis. Okay, we might find that at some market price, let's say a market price of $10, whatever the unit is, we might find that 8 units are demanded. Okay? Now this is one point on what is called the inverse demand curve. The inverse demand curve is price as some function of quantity. Okay? So you have the price as like the outcome variable, and it's some function of quantity. We call this the inverse demand curve, and this is what we plot. I'll go over this in a little more detail in a second. Okay, so this is one point on the inverse demand curve. We might find that if the market price was a little bit lower, let's say it were $8, that the quantity demanded would be 10. Okay, so this is another point on this inverse demand curve. And you might also find at a price of, let's say, $6, that 12 units are demanded. Okay. Now we could presumably impute points on the inverse demand curve between these points that we found by connecting them, let's say by using a straight line. Okay. So this is the demand curve, or inverse demand curve. I'm just going to put a D, but it's really the inverse demand curve. Okay. Now we're also going to plot an inverse supply curve. Okay. We might have, let's say, at a price of $3, if you add up the amount that all the suppliers in the market are willing to supply at that price, you might find that they're willing to supply 2 units. Okay. And you might find at a price of $6, they're willing to provide 4 units, etc. Okay. And so if you were to connect these points here, you would get the inverse supply curve, which is shown in red here. Okay? And the equilibrium is the price and quantity where these two lines intersect, where the inverse supply intersects the inverse demand curve. Now I want to take a step back for a moment and just mention that whenever we're plotting something, we're plotting the inverse demand curve and the inverse supply curve. That is price as a function of quantity. I myself and a lot of other people sometimes just say that we're plotting demand. But if price is on the vertical axis, what we're really plotting is the inverse demand curve. Okay, so let me help clarify what I mean by inverse demand and inverse supply versus demand and supply. So let me write down a demand function. We might have that the quantity demanded is equal to 18 minus the price. Okay. Now we could solve this for the this is the demand curve. We could solve it for the inverse demand curve by adding price to both sides and subtracting the quantity demanded from both sides. Okay, so we were to add, and I'll do this in red here, we were to add price to both sides and subtract quantity demanded from both sides. Okay. This price cancels this price. This quantity or this Q cancels this Q. Okay. And what we're left with is price is equal to 18 minus Q. Okay? So this latter equation is the inverse demand curve. Oh. Whereas this equation that we started out here, where we had quantity as a function of price, that was the demand curve. Okay, so when we plot demand, we're always plotting this. But often when we're solving for equilibrium using equations, we'll work with the demand curve. Now a key point here is that the inverse demand curve and the demand curve contain the same information. They both relate quantity demanded to price. So the demand curve does that explicitly. It relates the quantity demanded to the price. Whereas the inverse demand curve tells us at what price a certain quantity is demanded. But they contain exactly the same information. One is just the rearranged version of the other. So let's take a step back and let's solve a problem using equations. Let's solve for equilibrium in a partial equilibrium setting using the methods that we usually do. So what would we usually do? To solve for equilibrium, what we're going to do is we're going to set the quantity demanded equal to the quantity supplied. And in this example, the quantity demanded is going to be 18 minus the price, and the quantity supplied is going to be 2/3 times the price. Okay, to solve this problem, all we have to do is we have to solve this equality here. So what we can do is we can add price to both sides. Say plus price. And here this P cancels this P on the left-hand side. And what we're left with, 18 is equal to 5/3 times the price. And if you were to solve this a little bit further, you would find that the price is equal to 54/5. And you could take this price and you could plug it either into demand or supply. You should get the same answer either way. If you were to do that, you would find that the quantity that is transacted in equilibrium is equal to 36/5. So in this short video, we've shown how to solve for equilibrium in a partial equilibrium setting using graphical analysis, which should be a review, and also using equations, given some assumptions about what demand and supply are. We also went over what is the difference between demand and inverse demand, and what is the difference between supply and inverse supply.